This is a simple schematic diagram of a voltage divider. Basically, it is just composed of two resistors connected in series, and we will be talking more about that in the next couple of minutes. Hello, welcome to another episode of Physics is Easy with Mr. Jesse. In this tutorial, we are going to derive the voltage divider equation. So for example, if this is our voltage divider composed of resistors 1 and 2, I'll call this R1 and I'll call this R2, connected to a power supply. And we label our power supply as delta V. So here we will have delta V1 and here this is delta V2. So basically, if we would want to know the voltage across the second resistor, or V2, that is just equal to delta V multiplied by the value of the second resistor plus divided by the sum of R1 and R2. And we will be deriving this equation in the next slide. In order for us to derive the equation for a voltage divider, it is important to understand what a voltage divider is.
A voltage divider will allow you to divide the voltage between two resistors, and therefore allowing you to step down the voltage from a power supply to any other voltage that you require. For example, there is a 12-volt power supply powering this circuit. So what if I only have a 12-volt power source, but I only want 5 volts from the power source? Well, this is exactly what voltage dividers can do for us. By dividing the voltage between two resistors, you can adjust the resistance of each resistor to change the ratio of division across them, and therefore alter the voltage drop across each resistor. This will then allow us to make a connection across a resistor and use our desired voltage.
So now let us derive this equation, or the voltage divider equation. Once again, remember that a voltage divider is just a circuit composed of two resistors connected in series, and we have here our power supply delta V, or simply our total voltage. And say for example, we would want to know the voltage across the second resistor, or delta V2, or we could just call it as V2. So we would try to derive this equation using the properties of a series circuit. Now, talking about series circuit, we know the following: that the total current IT is just equal to the current that passes through resistor 1, and that is equal to the current that passes through resistor 2. We also know that the total voltage is just equal to the voltage across the first resistor plus the voltage across the second resistor. And we should also take note of the Ohm's law, that is V is equal to IR. Since we are interested to solve for V2, or the voltage across the second resistor, then we could write this equation as V2 is equal to the total voltage minus the voltage across the first resistor. Now, by virtue of Ohm's law, we could express Vt in terms of this equation. So we will have IT, since it's the total voltage, so that should be total current multiplied by total resistance, or equivalent resistance. And similarly, V1 would be equal to the current 1 multiplied by resistor 1. Now, since R1 and R2 are connected in series, again, since we have a series circuit, since series, therefore we could say that the total current is just equal to the current that passes through the first resistor, and that is equal to the current through the second resistor. Then we could write this equation, instead of writing I1, I could say IT, because after all they will have the same value. So I will have total current, or IT, multiplied by RT is equal to IT multiplied by R1. Again, this is because the total current is just the same as the current through the first resistor. I could then rewrite this equation, so I will factor out IT so that I'm going to have RT minus R1. Again, this is equal to V2. Now again, since R1 and R2 are connected in series, let me just write that down. Since series, RT, or the equivalent resistance, is just equal to R1 plus R2. As a matter of fact, this term here is just equal to R2. So that is because I will have R2 is going to be RT minus R1. So if we look at this equation, I could transform that into this equation where R2 is equal to RT minus R1, and I have here RT minus R1. So I could rewrite that equation further. V2 is equal to IT multiplied by R2. And once again, by virtue of Ohm's law, this is Ohm's law here, IT is just going to be equal to VT over RT, total resistance, multiplied by R2. And I could rewrite this as VT times R2 divided by the total resistance RT. I could then expand this further. Let me write that here. V2 is equal to VT R2 divided by, and what is RT equal to? RT is just equal to this. This is RT. So I can have, instead of having RT, I will have R1 plus R2. And rewriting all of these to fit in to the equation that we are solving for, instead of V2, I will write delta V2. It actually means the same thing, is equal to the total voltage is actually just this, delta V multiplied by R2 divided by R1 plus R2. And we have just derived the voltage divider equation. Similarly speaking, if this is the equation to solve for V2, then V1 is just equal to total voltage R1 divided by R1 plus R2. Or we could say delta V2 is equal to delta V, or just the total voltage, R1 over R1 plus R2. And that concludes this tutorial. Once again, always remember, physics is easy with Mr. Jesse.